Welcome, everybody. I'm Russ Graves. I oversee some of our innovation bridging efforts at MITRE Corporation. Over the last several years, we've been trying to engage with the innovation community down in Boston and in other cities to pull in innovative and novel solutions to the federal government. In that same process, there's oftentimes established and commercial products that are available that are enablers for some of that innovation. And we have an opportunity to welcome in IBM to talk about some of their solutions and how they're being used within the government to help expose data and put in capabilities that can allow you to bring different types of AI and computer vision to different solutions. If you're not aware, MITRE is a non-for-profit company, and we manage federally funded research and development centers to provide innovative and practical solutions to some of the nation's critical problems and challenges in defense, intelligence, aviation, healthcare, judicial systems, homeland security, and cybersecurity. I'd like to thank Marissa McCoy for organizing this event today, and then also introduce Cynthia Hansen from IBM's High Performance Computing and Data Analytics Solutions Group. She's put together a stellar lineup of interesting different topics across all their suite of tools to kind of give us a glimpse of the research in their quantum and brain-inspired computing that's resulted in software services and hardware capabilities such as their Power AI, their analytics, data science and development and collaboration environments, accelerated computing platforms, and cloud services. So we'll hear about those different capabilities as well as how they're being used within the government across several different programs, most specifically looking into Project Maven and also some of the SoftWorks. So please welcome Cynthia. Great.
Good morning, everyone. Thanks for joining us today. We took a look at Project Maven and its requirements and found that it really aligned very strongly with the capabilities that we've been developing all across IBM that we're going to talk about today. And I also wanted to talk a little bit about the DoD use cases that we see emerging for AI, machine learning, and deep learning. So to start off with Project Maven, this is the algorithmic warfare cross-functional team. And I sat through a couple of briefings by Lieutenant General Shanahan, who is the program manager for Maven. And he made a very bold statement that there will never be another weapon system fielded in the United States without machine learning involved. There's just too much data coming in too fast, and they can't make sense of it. So they know that they need to automate a lot of these processes and be able to find actionable intelligence out of that mass of data. And they say that it's insights at speed. And I'd like to add at scale to that statement, because the one thing that they're looking at is real-time analytics and real-time intelligence, but I don't think that they fully understand how that needs to scale out in order to remain at real-time speed. So this is a massive program. I've been briefing IBM management on it. In 2017, they spent about $100 million on research to field a couple of algorithms in the end. In 2018, they plan to spend about $300 million, with the bulk of the money coming in 2019. I've estimated that at around $500 million, and then I think it's going to turn into a B for billion dollar spend once we start seeing insertions into programs of record. Those baseline systems, obviously, from an industry viewpoint, are what we're looking at, and we are not only trying to talk to the government now about what our capabilities are, but make sure that our solutions are designed in to whatever they choose. The first thing that Maven's looking at is the PED scenario, which is process, exploit, and disseminate, and full motion video, and isolating objects within that full motion video feed, and then to fuse those together from several feeds and make sense of that data. So, excuse me, IBM is aligning and mapping its capabilities to this mission across the first two tasks, which is label the data and develop the algorithms and test them, and then increase those compute capabilities to keep up with that massive amount of data. So we've already briefed the government and industry day about our capabilities, and they feel that IBM has some of the best technology across the board of what they're going to need for Project Maven. And then we're submitting white papers. We're talking to various functional users who are generating requirements for Maven, and we hope to have that come together in somewhat of a perfect storm for our capabilities to be inserted into those programs of record as they're developed. So if you look at IBM's Project Maven capabilities, I lifted this slide directly from the industry brief that we gave the program office, and you see our groups outlined in blue. These are the four major parts of IBM, and then what we feel that we offer from those major business units into various areas. The applications are the DoD use cases that we're seeing. We have Watson, of course, our IBM software with predictive and statistical analysis, and our data science experience platform that you'll be hearing about in a few minutes. From IBM Research, AFRL has already purchased a True North system for prototyping, and we are also making great strides in quantum computing research. And as those technologies become more developed, we will then productize them and bring them into the market. For global business services, we have a lot of mission expertise and tactical edge applications we've already deployed in a number of theaters. And then my colleague Randy Thompson is going to talk about some of the customers that we've already, some of the platforms that we've developed around accelerated computing and how to manage that massive amount of data in a coherent fashion. We also are going to talk a little bit about Project AI, or Power AI, which is our software framework that incorporates the leading AI frameworks, a lot of technical and scientific libraries, and some tool sets including AI vision and large model tuning. And finally, a lot of the technologies that we offer in the cloud, on-prem or local, and then in hybrid fashion. So we're going to talk about how we deploy these solutions. So whether a customer needs them on-prem because of sensitivity, they want to offload a lot of their processing into the cloud, or have the capability to go back and forth, IBM can do that. And then finally, some of the examples of the customers that we're currently working with, and we'll be highlighting a few of these throughout our talks today. But Department of Energy is an interesting one in that DOE bet the farm on IBM to create their largest next-gen supercomputers that we're in the process of deploying today at Lawrence Livermore and Oak Ridge Labs. So finally, the key DoD use cases that we're seeing. Overwhelmingly, object recognition is at the top of the list, especially when we're trying to pluck something out of streaming full motion video. And we'll show you a couple of examples of the type of things that we're doing. One of my favorites is the bank robbery, where you see a guy come in and fumble with the gun and start shooting the place up, and the guard ends up shooting him. But the goal of the bank then is to learn from that and prevent the guy from coming in the door in the first place. So with facial recognition and machine learning, they'll be able to identify suspicious behavior, pulling a gun out of your pocket and locking the doors before the person actually is able to come into the bank and cause havoc. So That'll be an interesting one to follow. Sensor fusion. We're at the Hanscom Mill Cloud right now. Sensors is working on a project, and it's based on an IBM technology and IBM computers. They are taking a range of feeds, including human observation, cockpit instrumentation, inertial, and GPS data, and fusing it in and experimenting to develop the next-gen navigation system for military aircraft. So that's a great example of how to take multiple feeds and multiple groups of data and make more sense out of it. That feeds obviously into our country's ISR efforts. The tactical edge applications that we've developed are helping groups like SOCOM be able to react quickly to changing mission conditions on the ground, and even to do unsupervised machine learning. So if something changes, you don't have to rewrite the algorithm in order to proceed with your mission. Predictive maintenance is going to be important as we continue through time, where if there's an aircraft that is experiencing trouble, we can try to see if we can recommend some fixes before things get bad, but we'll be prepared to go right at that when it does land, and then to be able to say, you know, this aircraft should come off rotation because it's due for whatever. And because of how it's acting or behaving in operations, we may need to step that up. So all important things there. And then it's not only warfighters in the field that this technology can help. It can also improve supply chain operations and improve healthcare with personalized medicine. And our Watson group has made great strides in the area of oncology for personalized medicine. So we're going to move on to the next presenter, which is our friend Lisa Amini from IBM Research. Is Lisa on? I'd like to welcome Lisa Amini. She's the Managing Director of IBM Research in Cambridge and the Acting Director of the newly established MIT IBM Watson AI Lab. Lisa's an IBM Distinguished Engineer with 25 years with IBM and has been instrumental in our research and development of our streams statistical analysis solution. So with that, Lisa, take it away.
Okay, first thing is just introducing myself. You know, as was just mentioned, you know, I've recently moved to Cambridge to start this new MIT IBM Watson AI Lab and to lead the larger IBM Research Cambridge initiative. It's an incredibly exciting role, and we've been able to already, even though we only announced this lab in September of 2018, we've already been able to accomplish quite a bit in terms of getting our first set of projects up and going. And the MIT community has been really just fantastic in terms of the outpouring for, you know, bringing, you know, not just in the, you know, the CSAIL, the AI department, but all the departments bringing, you know, their deep expertise to these problems, and most importantly, collaborating with our researchers. So the first slide, the title slide, was basically our first event where, you know, we brought our posters so that, you know, we could help to meet collaborators at MIT where we didn't already have connections. I think what was wonderful about this event was we just invited them to come and meet our researchers and said that we'd have posters. And they basically printed their own posters and brought those as well. And so it turned out to be, you know, even though it was only a couple of weeks after we announced and very little advance warning, there were about 50 IBMers, 50 MIT folks. We had about 25 posters. They had about 25 posters. So we feel like we're getting off to this really great collaborative start with MIT. Okay, so one of the things that I wanted to do as well is to, I'm sure you guys know a lot about IBM Research, you know, in terms of, you know, our AI program. I'm sure you're very well aware of, you know, the Watson winning Jeopardy in 2011, the fact that, you know, we have a very, we take on, you know, kind of a very academic, industrial academic approach to research. So we, you know, we have quite a bit of recognition for our research in terms of Turing Awards and National Medals of Science and Technology and so on. But your name is only as good as your most recent results. So on the second slide there, I put a couple of just 2017 accomplishments to put things into perspective. So in 2017, we announced the world's first 50-qubit quantum computer. To put that into perspective, we are seeing, other people who are in this field are kind of at the point where they can release 50, or they're preparing to release 50-qubit simulators. But we're talking about 50-qubit actual real computer. We've not only, have built this computer, we also have a simulator as well. You'll continue to see advances on that. We've made access to being able to get in and experiment with quantum computing and start to program it accessible through the cloud. So this is an exciting part of our program. In 2017, we also demonstrated 95% scaling efficiency for CAFE deep learning, framework and models. We demonstrated that we were able to efficiently map algorithms that would compute the lowest energy state of small molecules onto quantum computing. When we say efficiently, the key here is that it's one thing to be able to map an algorithm onto the quantum computer, but to actually be able to exploit that exponential acceleration over traditional computers, that's where the challenge is. And this is an example of where we were able to actually get this. And we were also recognized by Nature in 2017 for being the leading corporate institution for high quality science, number one, basically on that list. So yes, 2017 was a very busy year for us, and all of this is including, is basically also this page. What I've gone through so far isn't including the what we did with the MIT IBM Lab. So on slide 3 is where I talk about the what we're doing with the MIT IBM Watson AI Lab. So we announced this on September 7th of 2017, and I think that if you, what's interesting about the announcement, if you go and read some of the press releases, you actually can read between the lines a lot about the way we were thinking about AI and this commitment and the future. So let me just kind of break it down a little bit for everyone. So it's first of all, it's a 10-year commitment, and we really feel like 10 years is the start and kind of the minimum that we wanted to put out there in terms of the commitment. So it's $250 million, 10-year commitment to jointly create the future of artificial intelligence. The reason why we wanted to do kind of out of the gate a 10-year commitment is what we see from some of other industrial research or corporate institutions that engage in research is they might go in and kind of buy out a lab, so to speak, right? Uber did this with CMU in terms of the self-driving cars. We don't see it as a point in time sort of thing where we just want to go and get kind of the brightest in the industry and apply them to our problems. We see it as an ongoing relationship, and essentially it is our number one key focal point for our strategy and for our products going forward. So it's not something we just kind of needed to start up quickly. We have research scientists. We have research scientists that have been working on AI for many years, and so that's not what we were going after. We wanted to we wanted to make a statement that this is long-term and strategic for us. Secondly, we wanted to make a statement that we feel that it's important that we not only collaborate with MIT in this way, but help to invest in the pipeline of students and graduate students and postdocs to continue to develop them in a way that we feel is, not only, includes kind of the scientific rigors of what they would get from MIT, but also helps to position them into certain real world problems that we know are impacting the AI field. So the second really kind of important set of announcements around this were the areas that we announced. So first on this list is fundamental advances in AI algorithms. This is clearly the biggest part of the program. We see that while the advances in deep learning are, frankly, they're all inspiring, right? I mean, these are problems that we and the entire academic scientific community had been working on for decades. We had started to plateau in terms of error rates for perception, image recognition, or speech recognition, these sorts of problems. And then suddenly, with the ability to build these very deep pipelines of neural networks, we were able to break through and surpass human error rates on certain tasks. So we feel that's fantastic, but there's so much more that has to be done here, right? If you take a more critical look at what's been done, a lot of the work there in terms of deep learning is still in the vein of being able to do classification, perception type tasks, prediction type tasks, but not so much the ability to really go to higher orders of reasoning with these algorithms, not the ability to incrementally learn over time, even if the environment in which the algorithm is deployed, or especially if the environment in which the algorithm is deployed is non-stationary, is changing over time. The algorithms don't tackle that well. They don't tackle well learning with very large sets of memory, being able to augment those memories over time. And so, as I was saying, that the largest part of the program is to really take a critical eye to these AI algorithms and go after those areas of research that will expand the capability, especially in the field of what we refer to as learning plus reasoning, meaning reasoning off of the representations that we're able to learn and hopefully learn in as unsupervised a way as possible. So that's the biggest part of the program. There are other parts of the program that kind of support and help us to accelerate that. So I'll go through those right now. So one is what we refer to as physics of AI. This is essentially and primarily AI for quantum computing and quantum computing for AI, meaning how do we, the first part in terms of, AI for quantum computing, the ability to apply our, machine learning algorithms to better manage the state. For example, one of the challenges that the folks in the quantum computing department have is being able to manage the state for the quantum RAM. I'm presenting to an audience right now. I'm presenting to an audience right now. Thank you.
Lisa, your slides are up.
Okay, great, thanks. Oh, that's funny because I still can't see them, so I'll just, I'm on slide 3. Okay?
Yep, you're good.
All right. Okay, great, thank you. So AI algorithms or machine learning algorithms to better control the state of the quantum RAM. And then secondly, we're working with we know that or at least our colleagues in the quantum computing department are telling us that, that we should probably expect that there will be, low hundreds of qubits in the, relatively near-term future, and that the, bandwidth, the memory bandwidth between the traditional architectures and the quantum architectures may be somewhat, limited. And so how can we take the algorithms that we know are impactful in machine learning, deep learning, and map those onto the quantum computers in a way that we can take advantage of that quantum acceleration? So that's basically what we're doing in this physics of AI theme of the program. The third theme is AI transforming industries, and we've really focused on 2, healthcare, life sciences, and cybersecurity. And the reason we focused on those 2 is because we see that, or we believe that both of those are ripe for disruption. So healthcare, life sciences, because that community has, that research community has done really, in my opinion, a fantastic job of creating a lot of structured knowledge artifacts. So there's the, the gene ontology, for example. There's snowbed clinical terms. So they've gone out and they've created certain representations of their domain that will help us to learn, attach to observational data, and bring to a representation on which we can do some of the reasoning, higher orders of reasoning that we'd like to do. And cybersecurity is slightly different. It's not that they build up those structured knowledge representations. What's different there is that we feel that, the people who will try to attack, our systems will be using more and more advanced AI techniques. And so it's critical that we figure out how they're going to do that, in advance of them doing it by trying to create our own AI algorithms, use that to understand the vulnerabilities in our systems, and also use it to make our systems, strong and robust against those types of attacks. So that's the third part of the program. And the last part of the program is, if you looked at the announcement, we said we wanted to do this lab for, AI for, societal benefit, right? We wanted to make sure that it's about augmenting and helping humans. And so as a part of that, we also created this theme that is advancing shared prosperity through AI. And the goal of this theme, we've actually got a couple of projects that we're working under this. One of them is to say, we need to ensure that as we're creating these algorithms, we think not only how to make them scalable and efficient and, as high accuracy as possible, we also need to ensure that we bring in, learning characteristics that reflect the types of decisions that, we consider valuable. So decisions that don't suffer from, discrimination or bias, that somehow bring in our ideals of what it would mean to do moral reasoning. And that's maybe easy to say, but that's a very, very challenging, difficult area. We truthfully, we don't even know exactly how to do this at this point. Some people would say, well, maybe you don't. You just need to ensure that the data that you train with reflects those types of decisions. Others feel that we need to think about, how we might formulate, constraints or, ways to map from, from these types of ideals to reward signals that we could use for reinforcement learning. And so there's a lot of talk of this in the community. IBM was, in a leadership position where we announced this partnership for AI with several other companies to ensure that we were creating AI responsibly. And this is to try to get down to the more technical details and to the research, and to do it collaboratively with MIT. We have other projects in this as well. We're working with the MIT economics department. Our expectation is that AI isn't going to displace entire, professions, but certainly it will change the tasks, and it will be able to take on certain tasks that humans perform today. And so how can we look into the future, understand the types of tasks within a profession that AI might be able to take on, understand how that might shape the professions and the education requirements for those professions, and then try to, support that both with the types of technology that we create, and then on the MIT side with the, the way that we educate people as well. So this gives you a bit of an idea of the overall program. On the next slide, slide 4. Yes.
Hi, it's Cynthia. Unfortunately, we are out of time for your segment, but we will be gathering names of folks who are interested in engaging with you in your group, and we'll be in touch shortly with some folks who are interested. So thank you so much for joining us today.
Okay, great. Thank you. Thanks, everyone.
Thank you.
Okay, bye-bye.
So next up is Cameron Hunt from SoftWorks. Cam, are you on?
Cameron, you're now unmuted, so you should be able to speak.
All right, can you hear me now?
Yeah, hi Cam, good morning, it's Cynthia. I'd like to welcome Cameron
Good morning.
Hunt, who's the CIO of SoftWorks. That's the collaboration between SOCOM and the Doolittle Institute. And Cam's career has been spent in applied R&D in IT. So with that, Cam, over to you.
Good morning, everyone. What I'd like to talk about today is how our organization is approaching data science from a perspective that applies to the special operations community. Now, SoftWorks itself is a collaboration platform between the U.S. Special Operations Command and a nonprofit called the Doolittle Institute. And we use SoftWorks as a way to bring in many non-traditional folks together in one place that is an unclassified, non-sensitive environment, very open and very collaborative. One of the challenges of trying to explore how data science would work for the special operations community is realizing the unique nature and way the special operations community actually operates. So while many organizations and enterprises talk about having big data, in the special operations community, we talk about having very diverse or dirty data from many different sources. Because many of the operations the special operations community actually conducts are highly classified and sensitive, the way we're getting after this is to actually set up a wargaming platform. We call this particular platform the Mad Jack's Game Range. Now, Mad Jack Churchill was a British commando in World War II. If we go to the slide where we talk, slide number 2, you can actually see in the background, in the bottom right hand of the slide, a gentleman carrying a sword, and that is Mad Jack Churchill. He went into combat with a bow and arrow, a sword, and bagpipes. He was captured by the Germans twice and escaped twice. He was a character, and he lived to a ripe old age. And we like to have inspiration from different folks in the community. My apologies. The way we're setting up this wargaming range is to generate data that is consistent of what a tactical operation would be. And then our data science team and our mosh pit collaboratively work together to explore how data science techniques can enhance the operations. So if you think about what a wargaming scenario or environment is we have a red team and a blue team, as we call it. So the red team attacks and the blue team defends. And through these scenarios and the instrumentation of this wargaming range, we come up with different kinds of data sets. The team then will take those data sets, they will prototype them, and send them back in to the red team and the blue team. So if we go to slide 3, you'll see the overall architecture of how we're kind of getting around this approach. So it really is the idea of, hey, iterative war games, generate data, data flows out, we do data science magic to them, build prototypes out of them or proofs of concept, go back and do some initial validation. And essentially, because we're doing this in concert with our war fighters, our special operations, actual operators, as we like to call them, they come out with prototypes that have some level of validation and can be matured. If we go on to some of the subsequent slides, you'll start to see, and actually slide number 4, which should be the blue team slide, you'll see some of the different types of data involved. There's 6 major areas that we're looking at. So when we talk about digital data, inside of digital is actually traditional cybersecurity data, so think packets and TCP/IP, but it also includes radio frequency data. If you have heard about Internet of Things or smart home devices, industrial control systems, many of these have radio frequency capabilities that aren't traditionally TCP/IP or what we would call digital networking, but they can still be vulnerable and or exploited for certain effects. other types of data, moving on to what we call the physical data. This is really about physical presence. So think anything from cameras to passive infrared to locks and access control badges. All of that is data as well that is relevant. And the last major area is kind of publicly available data. PAI is what we call publicly available information, and social media. So that becomes another rich set of data that comes into the special operations community that we have to be aware of. So 6 related but very different data sets in and of themselves, but they're all something the special operations community looks at the same time when they're conducting a tactical operation. So data science for us is again different, and the timing is also really intense. So there are moments when the special operations community, these missions, these units have only hours to conduct an operation, and so data science also has a high rate of high pace. This is reflected in our choice in some of the equipment that we're evaluating. IBM has, colloquially called the Minsky box, and forgive me if I don't remember right now the entire nomenclature. But what is unique about this GPU appliance is that some of the decisions from an architectural perspective that were made allow it to perform at a very, very high rate of speed. And again, that's important for us because we're not just doing monolithic data science. In other words, we're not just doing machine learning across a single type of data. We're actually doing our data science within and across. So I'm not just matching all pictures of a certain vehicle. I'm also taking a radio frequency data related to vehicles, as an example, and matching that back to the actual pictures and images of the vehicle itself. So again, not really traditional or compared to what we've seen in a lot of places. And it's taken us a long time to really understand the limitations of data science, how it could be applied to us and our community, and how we can explore in kind of a conversational way with our end users and customers about what really applies to them and what doesn't. There are other details on this slide deck that I could go into, but I wanted to stop and see if there's any questions.
Not in the room, Cam. Thank you.
Okay. All right. I'm not certain my time. I can go into something further if anybody wants, but I think I covered the essential major points of what I wanted to discuss.
Cam, could you describe in the remaining minutes a little bit about your facility and some of the hackathons and challenges that you've hosted, and describe the Thunder Drone?
Oh, absolutely. One of the ways that we have attempted to bring in new thinking is by launching a series of prize challenges. And we've now moved from hosting in-person events. We still do that occasionally, but we've launched a website called Teamworks, where the WERX, teamworks.org, that's where we take different conundrums or questions or problems from the special operations community, and we actually turn them over into challenges that the public can compete against. And they last anywhere from a month to 4 months. The prize money for first place can be anywhere from $5,000 to $50,000. And these challenges can include anything from building a better bow bumper to a better scope for a rocket launcher, and then to elements of data science. One of the projects currently listed is the City Systems of Systems model, where we're attempting to look at different dependencies and connections of urban areas to understand risk factors for stability, especially as military operations might happen in a city. What are the areas that we have to be aware of? Other challenges that we expect that are going to be posted this year will deal with radio frequency analysis, machine learning of novel text analytics and social media. And there could be, we think, some I won't say traditional, but more straightforward object recognition tasks, except where the objects or even the activities from video will be specific to the special operations. We also have a really open environment in Tampa, Florida, work with us. And we have tables, it's almost like a special operators tour.
Cam, you're starting to break up. And we're at the top of the hour. So thank you so much for joining us today. This was very informative. We very much appreciate your insights into data science. Thank you. So do we have Scott Souter on?
Yes, you do. Good morning, everybody.
Good morning, Scott. I'd like to introduce Scott Souter. Scott's IBM's Global Offering Manager for Deep Learning and AI. And Scott has a deep background in high-performance computing and technical computing, as well as business development. So, Scott, over to you.
All right, wonderful. And I'm not seeing my charts on stage. Do you want me to share those locally?
So they just came up, Scott.
Okay. Yeah, something seems to be a little bit crazy this morning with Skype, so I might be flying a little bit blind here.
Just name the slides you'd like us to
good morning,
forward,
everybody.
Scott. We'll forward your slides for you here, Scott.
Chart 2, please. All right, so good morning, everybody. I'm going to talk a bit about Power AI today, which is IBM's offering within the deep learning market space, and just to sort of roadmap where we are in the universe of things here. We've seen a lot of advances in the past few decades around cognitive computing, and in particular using data as a way to better understand data. And we've seen this expressed really in the past couple of years, with the past couple of decades, with the rise of things like Hadoop infrastructures that are really fundamentally based on this idea of machine learning, where we sort of jumpstart the system with algorithmic information on how to slice and dice data. And with the application of more and more data, the system refines its ability to understand and present what it is seeing as trends within data. This has created a lot of capability around novel ways of understanding where there may be information locked in really just huge seas of data. But machine learning hasn't been as good in some application segments as it could be. And in particular, this has been the case with things like computer vision application and image recognition apps. And this is where we've really seen significant advances in the past, really half a decade, in the past 5 or so years, with a new technique for machine learning and cognitive applications called deep learning. So deep learning really takes this idea of letting the computer, letting the system analyze and look for patterns in data a step further. And it uses a programming technique called neural networks in order to find connections and weights between data elements. And there's a lot of good information on application of neural networks and techniques within neural networks, which is available as part of a series of education segments through different sources. So I won't dig into it very deeply, but that might be something that we'd be happy to explore with you and your teams at some point in the future. The upshot, though, of this capability is that we're able to get a much higher level of precision in doing image analysis applications. And this has significant implications for things like aerial surveillance, public safety applications, as well as in the medical fields, things like diagnostic assistance and being able to look for anomalies in a MRI, for example, that could indicate a significant problem. Next chart, please. And with this sort of rise in capability, there's been we're definitely on the upswing in the hype cycle around deep learning. But there is a good reason for this, as we've seen that this technique has become increasingly popular as a way to get better information out of data. We've seen this happening because we can actually get a far more precise view of some types of data by using deep learning versus more traditional machine learning techniques, and also more traditional analytic capabilities. Next chart, please. But we have a long way to go. If we use the Steve Jobs continuum, we're far more on the iPod generation than we are the iPhone X generation. And really, particularly, this is a case because in many instances, we find that the software is not robust enough yet to scale at very, very significant scale. We find that the tools are extremely challenging to use. And we also find that technical limitations in the way that the software has been written really force us to make trade-offs as we do some of the analysis that we are doing using these deep learning tools. And so it's really sort of on those three areas that we see as holding us back, that IBM has focused our efforts in improving deep learning and making these types of applications more capable and more powerful. And I'll talk about that in the next 10 minutes of my time here this morning. Next chart, please. So I'll start with a premise, which is that building a deep learning application is really like you're creating an application pipeline. You're looking at something that spans all the way back into accessing and preparing data so that that data can be then brought through a system that can build those weights and connections and understand the patterns within the data. That preparation stage and then that middle stage, that training stage, consume a huge amount of time, typically within the application development process. And then you have to figure out how you can effectively insert the learning from this capability, what is called the inference model, into something that acts on existing and new information that is coming into your systems. And next chart, please. That really starts to play into a team of folks that sit across your organization. And when you look at how these folks interact with the system at different phases of the project, you sort of get an understanding for why this is really a team sport when you talk about data science. And so with Power AI, what we're trying to do is to help bring all of these folks into the process of developing a set of deep learning applications and capabilities. And we're doing so in a way that gives them access to intuitive tools tools that help assist them in sharing and collaborating across the process. So next chart, please. And really that's sort of our design goal here. With Power AI, we're trying to make deep learning better across this entire continuum, this entire group of individuals. So let's talk about very specifically what we're trying to achieve with Power AI. Next chart, please. And if you kind of click as I go, that would be helpful. So one of the first challenges that we have in actually developing a new deep learning model is that it's hard to get the systems up and running. In the same way that you would look at it's challenging to build a Linux system from the ground up if you go download something from kernel.org and compile it into a full instance of a running operating system. You're going to run into bugs. You're going to run into incompatibilities and challenges. And so in the same way that Red Hat or Cloudera or Hortonworks have really simplified the process of accessing complex open source software through a known good integrated distribution, we're trying to do the same thing with Power AI. Our original design goal was to help take all of the good work that's being done in the open source community around deep learning and make it accessible and up and running within about 5 commands and less time than it takes to go get and drink a cup of coffee. So we want to help simplify that process by bringing your environment up quickly and also very quickly update and upgrade your environment. And this becomes especially critical as you look at some of the complex software in this space, like TensorFlow, which has a dependency on 100 open source applications when you build it. We want to be able to rapidly get this in your hands. So the next challenge really is that it takes a long time to prepare data within a deep learning environment. When we polled data scientists, when we polled developers in the space, we found that on average, when you're working with a new data set, it typically takes 80% of the overall model development time to access, prepare, transform, and then load data into your system. And so one of the first things that we've done with Power AI is to tie it very closely to a set of Spark tools called Deep Learning Impact within the Spectrum Conductor product that help make this application happen in a parallel fashion. So you can load into memory your data and then rapidly transform it across a cluster of nodes. With this and with some of the tooling that we have developed around simplified data preparation, we're trying to draw that time down from 80% of the overall model development time to 30%. And then when you move past that data preparation phase, deep learning model training is a highly, highly iterative process. And so one of the things that we focused on in our work within IBM is how do we speed up these iterations? How do we take applications that are typically written to run on one system and churn for many, many, many days, sometimes many weeks? How do we take that and make that a application service that can be run in parallel across a cluster? And so we did a public announcement of this last year as a technology preview, a concept called distributed deep learning, where we simplify that model parallelization. And we have shown results where we've taken workloads that previously had run in 6 to 8 weeks, and we brought them down into under a day. So this allows you to more rapidly iterate and more rapidly get those applications in space. And finally, we want to make sure that you can take the capability that you've developed within your deep learning system and rapidly deploy it. Get it out in the hands of your DevOps folks, of your application development folks, so that they can get mission value out of it, so that you can have this capability, this analysis in the hands of your subject matter experts to help them in their decision-making processes. So next chart, please. I'll talk about 2 areas that we have really improved the process of deep learning, and then I'll show a quick example of some of the tooling that we're developing in order to get deep learning in the hands of non-data scientists and help bring them into the development process. So the first thing I want to talk a little bit about is the distributed deep learning capability. And this is really a high-performance computing way of addressing the complex compute challenge that a deep learning framework such as TensorFlow, Caffe, PyTorch, or some of the other tools out there bring to you. What we have done with DDL is we have built a communications infrastructure on top of traditional HPC tools like MPI, and we have improved the process of node-to-node communication and data distribution across an entire cluster in a way that very, very efficiently scales. When we did our initial tests of distributed deep learning, we were able to scale from one system with 4 GPUs up to 64 systems in a total of 256 GPUs, and we lost about 5% of theoretical efficiency. We scaled with 95% efficiency, losing very, very little capability to that communications process of distributing the nodes. We've since increased this. We've roughly doubled it in some of our testing because we were able to scrape together another 64 nodes, and we found that we continue to have that very, very low rate of loss of efficiency. So what this means is for every system you're adding, you are getting nearly the full power of those additional GPUs and that additional compute capability. So very linearly, you can look at how you can reduce the amount of time that you're spending in these iterative training processes. We think this is tremendously exciting. We've made this available to our customers in a very open beta for the past 6 months, and we'll be taking this into production very shortly this year as part of a supported Power AI deep learning stack. Next chart, please. The other thing that we've really focused on, and this is another capability that came out of the IBM Research team, is something that we're calling large model support. And this really gets at the notion of the fact that data scientists today have to make trade-offs in order to fit within the limited memory infrastructure available today on a GPU. Today, if you're developing a deep learning model, you typically have to put your entire model, which consists of multiple layers of a neural network, plus data, plus that batch training data that you're trying to work through as the system builds those weights and connections. You have to fit all of that into 16 gigabytes. And that becomes a significant challenge when we're talking about things like using very high resolution images, such as high resolution video or very large individual picture elements from a high resolution camera. And you're trying to pull that through the small real estate afforded to you by GPU memory. We've sort of taken that problem and thrown it away by using some capability that we have within our IBM cognitive system servers, where we make the GPU memory and system memory as part of a single coherent set of resources. We bring this coherency out with our AC922 servers that were announced towards the end of last year. And the outcome is that instead of limiting yourself to 16 gigabytes for an entire deep learning model, we can load individual layers up to 16 gigabytes of GPU memory and then cache the additional layers within that model into system memory. So we've effectively increased by 100x or more the capability and the complexity of these models. We're very excited about large model support. We think that this has significant implications, particularly in aerial reconnaissance, drone inspection, anything dealing with images. We effectively dramatically increase the level of resolution that you can pull through a deep learning system today. And the outcome of that is a more precise set of analyses and capabilities. So I'll move to probably my final slide, given time, and I'd like to talk about the one more thing that we're trying to do to increase the capability of deep learning, and that is that we're trying to really simplify the process of preparing data, developing deep learning models, and do so in a way.
Scott, we've lost your audio, so thank you very much for this very interesting presentation. So next up is Jonathan Entwistle. Jonathan, are you with us?
Good afternoon, everyone.
Hey, Jonathan, thank you. So Jonathan Entwistle is our big data platform engineer, and Jonathan holds a master's degree in predictive analytics, and he's here to talk about our data science experience platform and our cloud computing capabilities. So Jonathan, over to you.
So thank you for that introduction. I consider myself sort of a big data scientist. I've been trying to coin that term, but it's definitely not sticking. But if you want to reach out to me, there's my contact information below. I am here today to talk to you about primarily what we're doing in the field of open source data science. But I thought if you hadn't seen this slide already, I'd bring you back around and say, everything I'm about to show you today is hosted within our IBM cloud. And I'll take 30 seconds to talk about that, and then we'll move into the data science piece. The IBM cloud is built for AI in the sense that we're leveraging bare metal, like you just heard about. We've got a software-defined infrastructure, which can scale as much as you want, up or down. And we've built a base of open source technology, things like Cassandra, MongoDB, Postgres, on top of what we've traditionally done well, databases like DB2 or tools like Essential Data Stage. All of those go into a data framework which sits on top of the IBM cloud. We also have IBM federal cloud data centers because I know that's important for most of our federal customers. So we've got a lot of ability to deploy these AI-type solutions and solutions which are specific to our federal government in ways that other cloud providers can't. The last thing I'll point out is that our cloud is how you access the Watson technologies through a series of APIs, microservices, and things of that nature, which you can see up there. And so this enables you to build custom AI platforms that are infinitely scalable and have a better pricing model and elastic capability that you get with cloud-type solutions. What I'm going to be talking about today is the data science experience, which is something that's available as a service or can be installed locally on-premise or using the Power AI platform that you just saw. So if we take a step back quickly, if you're not familiar with the data science problem, I assume most of you are, I'll only spend a minute on this. The main point I'd say is you can't write code to say, if this, then do that 40 trillion times. It's just not scalable. And this type of machine learning is something that we've developed a long time ago, but only recently became really feasible through the advent of some of the platforms you just saw, parallel compute, these types of things. So we're seeing a huge uptick in how data science and machine learning is being used in the community. And what's great about it is that it's all based in the open source. So I asked my boss's boss's boss the other day, hey, what's happening to these proprietary platforms? IBM has the SPSS platform, and of course you're familiar with other things like MATLAB and SAS. And he said the rate at which the open source community around R and Python and Scala, Spark, is accelerating so quickly that no organization will be able to keep up with it. So we're fully embracing that. This sort of question is more focused on the predictive analytics piece, but I'll also point out there's an element of this called prescriptive analytics, right? If I can make a prediction, how do I best optimize the resources I have in a constrained environment to address that? For example, if you've got a single truck visiting 10 different locations, there's 3 million ways to do that. So it's a two-phased approach as well. So we'll address both predictive analytics, which covers machine learning, deep learning, like you just saw, and actually prescriptive analytics. So if you look at the field of data science, especially in the open source, I'm a Python guy, I'm an R guy, I know a little bit of SAS. You end up having a lot of problems with data being siloed. You're running on your laptop. We're all using different data sets, and it's hard to really get these models that we build on our PCs and get samples of data into a production environment. I can't tell you how many times, I've seen data scientists build really powerful stuff, but it never sees the light of day. So we went out and we interviewed over 1,000 data scientists and said to them, okay, you use tools in the open source. I've already mentioned a few of them, things like Jupyter notebooks or Zeppelin notebooks, languages like Scala or Python. What are the problems you have today? And we saw the same themes over and over again. We want to be able to use whatever tools we want, but we kind of want them to be standardized. That way, it's not a pain and we don't have to reinstall everything every time. We want to have help in preparing data, and we want to be working together on stuff instead of running on our laptops locally. So how do I collaborate better in the data science space? How do I merge code in the data science space? All that's pretty immature in the open source. And then at the end of the day, how do I share that data out? How do I share it within my organization? How do I share data within my organization? And how do I effectively get that model into production so that it makes a difference. And this is why we built the data science experience. So the data science experience allows you to develop in 100% open source code. Today's languages are Python, various versions of that, R, various versions of that, and Spark, which is programmed in Scala. And we wrap it with things that we believe are essential to success: security, collaboration, sharing, right? So we're adding to that open source while remaining completely neutral in terms of code. We're not forking anything, but we're allowing people to share and work with those tools. So what's under the covers here? I'll start over on the left. There's a community. You'll see a community if you log into our online version, and I'll show you how to get to that. But what's important about this is within each of our customers that I work with, and I work with a bunch in the government, across the DoD, Intel community, they all have their own pieces of code that would be valuable to share, or pieces of data that would be valuable to share. But there's security around that you need to maintain. It's hard to share very large volumes of data. So when we're building these models and iterating over them, it's important that we can basically say, hey, I wrote this. This piece of code calculates a certain measure that we need to determine a risk for a terrorist event, something like that. Publish that out and make it available to everybody strictly within your organization. So we have this idea of community. Secondly, is a completely open source core. So we're using Jupyter and Zeppelin notebooks as the primary way of doing our development. Although if you prefer other IDEs, or Python, or RStudio, for example, we've included that as well. The entire platform runs with Apache Spark underneath. If you're not familiar with Apache Spark, I'll get into it a little bit towards the end of this. But suffice to say, Spark, we think, is the next big thing in processing and machine learning of very large data sets. IBM's only ever built 3 technology centers. The first one was for Linux, the second was for Java, and the third is for Apache Spark, and that's the Spark Technology Center out in San Francisco. We're also including all of the deep learning libraries that you've just heard about, all the ones in the open source, Caffe, Keras, TensorFlow, all available, pre-integrated. And what's important about this for our Department of Defense and intelligence customers is a couple of things. Number one, we've included all the open source packages that we believe most data scientists use on a day-to-day basis, which means that you get code indemnity, we vet the code, we test it, we support it. And more importantly, we're not silly enough to think that we know every package that's ever going to be used, so we allow you to bundle together packages that you know your analysts are going to use, where you can control what they have access to, and you have a standard gold image of what they can use, which you can add to over time, change over time, continuously vet. That way you don't have folks in the intelligence community trying to get out to the internet to pull down packages from who knows where, right? Very important from a security perspective. And then last but not least, we've added project and team collaboration. So when I build out the technology here, I create a project, I can invite people into that project, and then they get access to everything I'm building. Those RStudio notebooks, the Jupyter notebooks, the data sets that I have access to, and that enables me to then make sure we're all using the same sets of data. We're all accessing it. We're not duplicating it. It can remain where it resides. If it's already in a Hadoop cluster or a cloud somewhere, we can leave it there and execute against it. But it gets rid of the problem where you've got people of varying skill sets and they don't know where to start. Or maybe that guy that developed all your code leaves tomorrow. How do I pick up the pieces? This helps with that. It allows us to collaborate over data science tools. And of course, we've got a lot of expertise in machine learning ourselves. So we include both our optimization engine, which allows us to do that prescriptive analytics, as well as our own machine learning engines, which come out of IBM Research and do things like automatic hyperparameter optimization, model selection. these types of things. So if I'm given a data set, I don't have to necessarily be an expert. With a couple of mouse clicks, the IBM's Watson sort of data platform technology can actually go through and tell you, hey, this model might work. Then I can hand that off to a data scientist who can go in and do something very custom. So if I'm specific about what it is, notebooks are at the core. And again, I'll reiterate, this is nothing proprietary, and there's nothing that's any kind of vendor lock about this. But we add the ability to do things like scheduling for notebooks, security around them and authentication, sharing, collaboration, where we can both be working on them in real time, things that don't exist in the open source and may never. So all the things that you build here are completely open source, but we'll do all the heavy lifting for you in terms of doing the pre-integration, setting up the servers. Like, for example, if you're an R guy, you might want to use Shiny to develop web apps. We handle all that for you under the covers. There's your R Studio and your Shiny, if that's your tool of the trade there. I did mention that we include prescriptive analytics with it. Very important here. The CPlex engine is what's underneath this. This is an IBM technology that is known to be sort of the industry leader for 40 years in a row, where I give it a set of problems, I give it resources, I give it constraints, and it spits out the best way to do that, be that logistics for the Air Force or optimization of people personnel on an Army base. We've built in that to the system so that from the same notebook where I'm developing my machine learning code in R and Python, I can also apply, this is what you should do now that we've made those predictions. Very powerful stuff here. This is an example of the community cards. These are searchable. These are completely customizable. You can create cards for notebooks, for data sets, for tutorials. They're all, like I said, completely searchable. I can click on them, and then I can integrate that into my own project. So if somebody else has done maybe a face detection algorithm, we're doing some kind of a support vector machine or something, I can click on it and say, hey, that's interesting to me. Or if someone I respect is doing work in the same field that I am, I can say, hey, tell me when this guy publishes cards, because I'm always interested in reading what he publishes from a data science perspective. Today, if you were to go out to the internet, you'd see IBM's version of this. But again, it can be customized to be done internally as well. Way to provide data science as a service for your own customers. I mentioned this earlier. We do have machine learning in a box. So we like to say clickers versus coders. So when I interact with data scientists or with data science experience, I'm really given 3 different ways to interact with it. I can do completely customizable, hand-coded R and Python. I can do the opposite end of the spectrum, which is a wizard GUI where I just tell it what data and what I'm looking for, and it will do everything else, including produce a model. Or we actually provide a GUI where I can drag and drop nodes, models, where I can build complex flows or data streams against different runtimes. So if you're familiar with SPSS Modeler and you want to use that technology, you can. Or if you want to develop your model in 100% pure open source Spark, I can literally drag, drop, and generate Spark code for you. Again, very powerful in how it works. So I said I'd spend a few minutes on Spark because we do believe it's very, very important to what we're doing in the mission space. And the easy way to think of it is that it's an engine. And what's a beautiful thing about it is that it's a parallel engine, and that the code that we write every day in Python or R can many times be easily translated into Spark R or PySpark. And what that means is that I'm no longer forced to run on a single node on my laptop. I can divide and conquer that problem such that I can scale it out linearly. So everything you see in the data science experience is also elastic. I can start with 2 cores and grow it to 300 cores. I can, with an on-premise instance of data science experience, add nodes as I need them. Very easy, very simple GUI tool to do that. And what's kind of nice about Spark is that we're really at the lead here in terms of Spark 2.0, Spark machine learning, where IBM is spending most of its time contributing back to the open source around Spark. is around the hardest problems: machine learning, SQL, streaming, graph. And you can see there our partner Databricks, and of course, us and our partner Hortonworks in terms of machine learning and Spark ML. So what's interesting about all this, for those of you that like Gartner platforms, is that data science experience recently got us, for the first time in a long time, to the very top of the Gartner quadrant. And it's not because of our proprietary engines, although I happen to be a fan of things like SPSS. It's because of that forward-leaning, forward-thinking, that everything is going to be based on the open source, but we need a way for the enterprise to be able to deploy it. And that's exactly what DSX does. It bundles everything together. It provides a layer of security and collaboration over it, and yet it doesn't impact your ability to pull down code from the open source. It doesn't impact your ability to export that out and run it anywhere. Or if some better platform comes, in a day or two, go for it. So DSX Local, by contrast to DSX Cloud, is a localized Spark cluster that runs behind the firewall. So you may be hearing about IBM Cloud Private today, which is effectively an open source, glue that mimics how public clouds work with technologies like OpenStack and Kubernetes. So we can exist as DSX Local on our own, or underneath something like an ICP, running on platforms like Power AI or Intel. And what's nice about that is we get complete integration with your current on-premise systems. So you can do things like access databases, create those connections, use remote Spark clusters if you're already a customer of Hortonworks or Cloudera. And if you don't have those in place, we provide them for you. So we provide a clustered file system, very high performance, clustered compute using that Spark engine, and everything you see in the cloud is available on-premise as well. So this is what that looks like, and this is the type of work that goes into creating data science as a service for an internal customer. Some of this is available in the open source, and a lot of it's not, right? For example, if I was to build out a compute cluster, how do I do workload management over that? How do I make sure that one user isn't using all the compute and another isn't? That's a little bit trickier in the open source. We provide all that for you. We provide the open source, we provide the storage and the compute, as well as GPU support. So all of our stuff has GPU affinity. So if you've installed this on top of a Power AI platform, you get access to all those libraries you just heard about. You get access to the acceleration of the NVLink and the NVIDIA GPUs. Really powerful. And so as I go through, I do often talk about how do I provide this as a service. And the reason I do that is because I've had many conversations within the Navy, the Army, and they say, we've got 3 or 4 good guys who are really good at Python and Spark, and then we've got about 400 that are learning, and we've got thousands of business intelligence folks that want to use this type of technology as well. How do I scale that out? How do I provide this as a service? Well, that's exactly what DSX Local is designed to do. So an IT shop could stand up DSX Local in 30 minutes, scale it elastically, and you get the following types of features that are really important. You get linear scalability. So as I need to grow in terms of workloads or data volumes, I can do that. By the way, we offer this simply by users. The number of people who are going to be actively developing Spark or R or Python code. So it does not matter how many nodes you have, how much data you have. If you have 2 users and a petabyte of data, you only pay for those 2 users. The compute and the storage have nothing to do with the pricing model. So in terms of that security, we also offer integration into your existing on-premise systems. So I can't get into this. I can't view data if I can't authenticate to my existing systems. I've got that workload management we talked about. I've got a web-based GUI. All of this is web-based. It completely interacts with FIT clients if you have them, but there's nothing to install if you don't want to. So the Jupyter Notebook service, the RStudio service, all of that is completely web-based. So it enables us to control it centrally and not have to worry about deployments, upgrades, these types of things. The storage on the back end uses commodity storage or things like object storage if you're in a cloud environment. which is far and away the least expensive but most scalable way that we can do this type of processing. So we'll use whatever you've got today, and if you need it, we've got stuff in the background as well. It supports nearly any kind of data that you can think of, structured, unstructured, although a lot of data science today is more focused on the structured data, all kinds of relational sources, and others, REST interfaces, SharePoint, they're all accessible. And I'll say this again because I think this is very important. We do bundle together all the libraries that any data scientist would need. We do bundle in and pre-integrate the deep learning libraries that you would need. We'll use GPUs if you can. But again, if we know as an IT shop that there are certain libraries that my guys need every day to fulfill their mission, I can build an image that's distributable or that's usable such that I can enable people to download their own code and their own libraries, or I can disable it and make sure we're all on the same page using the same code, which is really important for things like certificates of networthiness and the STIG process. Right? So we've got to support that. And by the way, this DSX local technology can be installed anywhere. It's completely containerized. So you could have it running on a laptop, you could put it into your government cloud, or you can have it running on premise.
Jonathan?
So that was the point of this right here.
Jonathan?
So I'm running out of time here, but I will point you to a couple of links, and you'll get this deck. We'll make sure you get the links. If you want to just play with data science experience, there's a sign up at datascience.ibm.com, and you'll be given access to our cloud environment. And that contains everything you see today. It gives you the ability to develop code, to run that code, to deploy it for nothing. There's no credit card required, and everything you're developing is open source. We run monthly or sometimes bi-weekly sessions on Spark, on data science and model selection, on DSX, intros for people that haven't worked with open source technology before. And we do that across the country. Most of our federal customers here are based in the DC area. So in DC, we run them out of our McLean office or in downtown, but there are certainly ones down south in all the major cities, including Boston, New York, and these are really good. There's not a lot of slideware, and it's all pure open source.
Jonathan,
really good,
thank
no
you.
cost.
Unfortunately, we're out of time
You are
for this segment, but thank you very much for these insights. IBM would like to offer the workshop participants some trial subscriptions to DSX, and we'll be following up on that through the post-workshop survey. So we're right at break time. We're going to take a few minutes here. We'll be back online at 9:50 a.m. Thank you. So we'll get started again. I'd like to introduce Bruce Saratani. Bruce is IBM's lead architect in IBM Federal for Big Data, and he's here to talk about our IBM Analytics Suite and predictive, statistical, and real-time analytics. Bruce, over to you.
Well, good morning, everyone. Appreciate your time today. I hope we'll make this a little entertaining and very informative. To get this rolling off right away, just to let you know who I am. As introduced, I am an IBM architect, but I spent 20 years in the Air Force, the first 10 years in electronics and aircraft maintenance, and the next 10 years in software development for logistics. So my background is around the Air Force, and I've enjoyed it a lot. But the last 25 years, I've been out and about with big data solutions, and the last 6 years here at IBM. To get this kicking off, a lot of people who actually want to get value out of data find it rather difficult to find any kind of data. They're out in the middle of the desert fishing, which is not very productive, as you might imagine. And maybe even more challenging is they actually have a data lake, but it's about getting two fish out of a frozen pond kind of scenario, and makes that life very difficult. And then finally, even if you do have a great data lake, a lot of times it's just filled with garbage, and the results are not very worthwhile. Wouldn't it be great, though, if we could get some wonderful results, and maybe just a bit of a stretch, but wouldn't it be great if the lake actually produced some valuable insight into your business and to what's going on? So what IBM like to do is to help you as the charter, as the fishing guide, to take it to the best waters and to get you the value out of your data. So to get to that, I'm going to talk about a process called perpetual analytics. Data comes in from the left to the right in its natural state, as it comes in streaming, whether it comes in as structured and unstructured data from transaction systems, and lands in an environment that makes the most sense for that data at that time. And being able to collect that data from a variety of sources at full volume and at full speed as technologies that IBM can deal with. We have solutions that, for example, the weather company is collecting billions of elements per day from millions of devices around the world. So we have the capacity to collect that kind of volume of data and maintain it. It's no longer required to do sampling or to take some of that data out. But as the data comes in, one of the greatest value adds from IBM is the integration between the tools. We've created a lot of great products, and we've purchased a lot of great products, but they all work together. So as data comes in from the left side, it then gets percolated down into the other data sources and the data stores that make most sense. Sometimes that's Hadoop, sometimes it's a massive parallel warehouse, but the point is that it comes in its natural state and then is easily moved into an environment that makes the most sense for that data. Okay? And we also have integrations that allow the warehouses that become maybe overpopulated and need to be thinned down a little bit to persist that data into a warm state back into Hadoop, which still makes it queryable. Again, we talked about this integration a brief moment ago. What if I could run a query that ran across all three of these environments? I don't have to have the data moving back and forth. I don't want to move them out in the data when I don't have to. So to that point, we have analytics that we can write that will run where the data is. In other words, move the question. Again, I went through the first few slides that show the data lake and its status. So if we go ahead to slide 3, and this is that fishing hole I talked about where there's very little results in a lot of harsh environment. Slide 4, the next slide, will be this great data lake full of trash that doesn't have a lot of value. Right? So slide 5 would be this environment where you actually have success and you're getting value out of it. Slide 6, again, was that environment where you could go fishing and get some results out of your data. And IBM like to be that guide to get you all that value. Right. So slide 7 should be a build slide. We've got data flowing in from the left to the right again. I'm going to briefly go through this slide again because I did talk to it earlier, but to that point, data lands in its natural state and it gets persisted in the data warehouse in Hadoop wherever it's necessary. And then going through and building the build slide, so you see the purple lines coming from the left to the right. Again, unfortunately, I can't see the room at the moment, but that data set can be a huge volume. Right? So we want to run analytics in near real time if possible. And we want to be able to run those analytics at the point of collection or even pushed out to the sensor, even having the analytics running at the ground station for the satellites, on top of a UAV, or anywhere, right? So the analytics being as close to the point of the sensor as possible so you can get the value as quickly as possible. So if you click on the slides for the build for slide 7, you should be at a point where you see a black line coming from the bottom going up, and that's gaining insight. So as more and more data is collected, we become more aware of the situation and can improve the analytics over time. Hence the term perpetual analytics. As we learn more, we make the analytics more intuitive, more responsive, more predictable based on today's events versus what's happened in the past. Right. So move to slide 8. These are known traffic patterns that fly aircraft in and out of O'Hare and Midway in Chicago. And that's the Great Lake of Michigan in the upper right-hand corner. We can understand through machine learning what an airplane does or what a satellite does, what their normal paths are. Now, they're not consistent every single day, but we can determine what norms exist. And there's an unusual norm here to the bottom right-hand corner. It's hard to see because there's so much other data on the screen, but there's a very unusual traffic pattern. And if you click to slide 8, you'll see that in a moment. So this traffic pattern on slide 9 rather, on slide 9 shows what's not a crop duster. It's actually a Google aircraft doing terrain mapping. But machine learning with Sandia Labs discovered through machine learning that there is a abnormal activity occurring out of all this massive amount of data. So I'm going to go to slide 10 for a second, and I'm going to pause for a moment. Are there any questions in the room or on the phone before I move on to the next section? Again, this was all a concept of how we can manage huge volumes of data and ask questions of the data where it resides versus moving the data yet to another location to do an analysis.
I think you can proceed, Bruce.
Okay. All right, so again, I don't see the room, but you should have a screen. It should be on slide 10, and there should be a play button here. If you can play the audio now.
What are you doing, and how are you using big data and analytics to address that?
Well, it's not just the opportunity, it's the necessity. I mean, you go to a bedside and you see a patient in a critical care bed. They've got 6 IV pumps running, a ventilator, a dialysis machine, a balloon pump. We have streams of data, rivers of data, torrents of data coming across the screen. There's no human being on earth who can amalgamate that data and make the right decision. But our task is to deliver the right care right now, every time, for every one of the patients in our ICUs. So our real opportunity with IBM and its partner Excel Medical is to amalgamate that data to create new types of situation awareness, where we not only perceive the data, but we can comprehend it, we can understand what it means, and importantly, we can project it forward into the future. So we know that the best care we're delivering is going to get the patient where we and the patient and the family and the healthcare system all want to be.
So you can imagine an ICU with all that data flowing around and all the hecticness of a NICU, of alarms and beepers going off, that they can be overwhelming with data. What's important, what do I need to deal with now, is really the critical factor. And that's what we're able to do with that kind of situation, is identify these are the critical issues that need your attention now. And, in fact, with predictive analytics, get to the point where we can look at multiple influences on an issue and tell you that this is going to be happening within the next 24 to 12 hours. Let's do something before it becomes a hair-on-fire situation, before the patient goes into a critical situation, prevent that from ever happening to begin with. Right? So that kind of massive amount of data in real time, and I'm talking about terabits per second kind of real time, not 2 minutes or 30 seconds, to be able to do things that you need to know about and do and take action right away. Okay. So slide 11, there's a process that I'm sure many people in the room are familiar with about descriptive versus diagnostic, predictive, and prescription. Basically it's what's going on, why is it happening, what's going to happen next, and then finally, what do I do about it? So IBM's taken this curve and applied various tools to get those things done. The kind of tools that IBM has, one of those is Cognos. It's gotten a great revamp recently with improved analytics and it's had great analytics for a long time. Its GUI hasn't been the greatest. We've done a lot in the last year to improve the visualization, the ease of use. This is really a self-service kind of environment for not just data scientists, right, but for people who actually need to make decisions on a daily basis. The mappings are intuitive. They can drill down. You can import your own images in place that make more sense for what's going on in your particular line of business. And on the next slide, I'm on slide 13. Content analytics. 80% of the world's data is in unstructured data, whether it's documentations or PDF files or anything else. So as a result, getting value out of that data is critical. One of those situations is Toyota has an issue in the past where the floor mats were impeding the ability to accelerate and brake. The complaints in actual text being sent to Toyota were illustrating this point, but nobody was able to read all the complaint messages to actually bubble up the fact that there's an issue with floor mats and acceleration. Using text analytics, you can research all the comments that people were submitting and realize there was an unusual amount of comments about the floor mats getting involved and getting in the way of the acceleration and braking capability of certain cars. Right? Other data sets are what tasking orders, right? Looking at the documents that task certain things, extracting that. And we're not just looking for words. We're able to correlate that this person requested this task to exist or happen on this date. So we can pull out data that's related to each other, not just individual pieces like a search, but actually the correlation, and then populate structured data sets to do further analysis on. All right, the other thing here about search is we can search across using natural language, not some special SQL skills, etc., but natural language across your databases, across documents, across SharePoint, a variety of data sources. So you can scan your entire enterprise looking for key pieces of information. Going to the next slide on 14. So the other part of this is to be able to predict what's going to happen. And you previously saw this data science experience, so I won't go into this very much, other than it's a great collaboration tool. It's a great place for data scientists and businesses to work together, having those recipe cards at the top and be able to develop code and then immediately see the results on another web browser of what that code is impacted is really a great interactive, collaborative way of developing tools. All right, slide 15, predictive analytics. The data is being collected, being analyzed in real time, but how do I know what to analyze and how to analyze it? And then once I do, what's going to happen next? What next thing is going to break, or what next action do I need to take? And that's where predictive analytics and a tool like SPSS, which is a drag-and-drop GUI that allows not necessarily your manager to take care of these things, but certainly a subject matter expert with a little bit of skill can develop these analytics to figure out what to do and what's going on and what's likely to break next. It's a very intuitive GUI environment. Again, going back to the original point in that slide that had the animation, it's the ability to connect everything together, things to flow. The biggest value add I can tell you about IBM is the interrelationship, the connectivity between all the tools that we have, data flowing from one to the next. You don't have to buy the whole blue stack. All these tools work with industry standards, open source, and many of them are actually based on open source, so that these tools can work with our full IBM stack and many of the tools that you've already invested in. So it's not a rip and replace, it's an enhancement of your existing infrastructure and investment. So I'm on slide 17 now, and we have to talk about the elephant in the room, right? Hadoop. So IBM and Hortonworks have worked together to create Hadoop, or to distribute Hadoop rather, and IBM has filled in some of those gaps. There's a variety of things that Hadoop does great, and there's a few things that it doesn't do well. And IBM is focused on those gaps. One of those is SQL, Structured Query Language, where many people use that for database queries. We're able to query data in Hadoop using the full breadth of SQL, not just the limited section that comes with open source Hadoop. And it's optimized using the engine that we've had for decades, so we get better query performance as well. And you can query data that's in Hadoop along with data in those other data sets we talked about earlier, maybe in a massive parallel warehouse or maybe in a transaction system. The data does not need to be moved everywhere. The big SQL or the IBM SQL enhancements can allow you to reach that data across all those platforms. And a variety of other enhancements within Hadoop that, if you like, we can give you a more detailed brief on the capabilities that our Hadoop solution has over other vendors. Moving on to slide 18, data's great, but back to that original garbage lake, the polluted lake that people were fishing in, if you don't have some governance, what's going in and what's going out, you're going to find yourself fishing in a quagmire of garbage and pulling up boots and old tires and not tonight's dinner. So the idea here is that you've got to have some governance across that data set. And IBM brings those tools to help you get value out of the data, not just collect the data and have it sit in a lake where it's not productive at all. All right. So the last slide here is 19. It's just a discussion slide. I would like to mention that we are working with the Air Force on a project around aircraft engines and its predictive reliability. what's about to fail across history. It's a challenge for the Air Force in keeping enough engines in inventory and on the wing. So we're working with the Air Force on getting that to be optimized so we have higher availability of systems. In addition, with the Army, we worked on a project called Stryker to help them figure out what's going to break on these defensive missile systems that we have deployed around the world, not only on how to maintain the equipment better, but maybe even to improve the reliability so that on the accuracy of the system itself, like the algorithm that it uses to determine when to fire, when not to fire. Is that a flock of birds? Is it another missile coming in? So the improvement of their analytics is also something we can help them with, in addition to the maintenance of and the predictive maintenance of the equipment itself. So for time sensitivity here, we want to open the room to questions.
Bruce, no questions here in the auditorium. Thank you very much for your presentation.
You're welcome. My pleasure.
All right. So we'll bring Randy Thompson up to the front of the auditorium and put up his slides. Randy is an IBM systems architect focusing on Department of Defense in our IBM Federal Systems Group. Randy's background is primarily in IT, focused on databases, systems, and storage, and also on big data initiatives within the federal government. So Randy, I'll turn it over to you.
Thank you, Cynthia. So I'm going to, is this mic on? Okay, we can't hear it from great acoustics here, I guess. Okay, so as Cynthia said, and thank you for the introduction, my name is Randy Thompson. Today I'm going to talk a little bit about IBM systems as it relates to AI, machine learning, and deep learning. That's going to cover or encompass the Power 9 systems and their unique capabilities as it relates to these workloads. It's also going to cover some software infrastructure components such as Spectrum Compute. Spectrum Compute is software that basically enables you to run many systems effectively as one. Okay. And Spectrum Storage in the form of Spectrum Scale. For some of you may know that as GPFS, but that is the underlying storage technology that we use in many of these types of solutions. So I'm here to discuss IBM systems, so you'd kind of expect me to dive into the systems, the processors, the I/O buses and that kind of stuff, but it's really about a lot more than the hardware. It's hardware and software working together, right? Because without the combination, we really don't have the ability to solve the problem. So IBM certainly delivers, a very differentiated system, which I'll talk about in a few minutes. But we also supply and support a differentiated software stack for AI, ML, DL activities. And you've heard a lot about those technologies today from Scott Souter, if you've been with us all day, from Scott Souter and other people. So really the way I kind of look at it is it's about co-optimization, right? It's not just the hardware, it's not the processor, it's not the GPUs, it's not the acceleration, it's not just the software, the AI frameworks, the distributed deep learning libraries, large model support, and those things. It's about all of it. And it's about all of it designed together to solve the problems that we're facing and that we're trying to solve. So, and you've heard a lot about many of these things today, right? But so IBM sort of started out by understanding the workloads and designing. Go ahead. Oh yeah, I'll have to stay. Yeah, thank you. Okay. So IBM started out by by designing systems by understanding the workloads and designing systems to support the workloads, and then it went a bit further, and it took the world-leading frameworks such as TensorFlow and Caffe and optimized those frameworks for use on the platform. So, some examples of those optimizations come in the form of Power AI Vision, right? So Power AI Vision provides a toolkit that enables scientists to work together with non-techies, right? If Scott had been able to continue, what you would have seen is a demonstration of a graphical user interface where a subject matter expert, non-scientist type person can go out, can identify various different objects within the image frame. They can tag them, and then the software itself automatically takes that image, processes those tags, and makes them available for the scientist building the data model. Spectrum Conductor for distributed deep learning is another technology that we've added, and this enables or provides a platform to help users run workloads and scale them across lots of different systems. As you heard Scott talk about earlier today, we've already tested that across 256, and it was news to me when he said 512 different GPUs at 95% scalability. That's pretty remarkable. And large model support is actually also really, really exciting. I was glad to hear Scott covering it. That basically enables us to build larger models using larger data elements, such as higher res images, right? So we're moving from, we're moving to 4K images, and we'll go beyond that eventually. So those are the technologies that IBM, some of the technologies that IBM has worked on to co-optimize the software with the hardware. So what did we do from a hardware perspective? I'm actually going to start talking about the hardware now, believe it or not. And when I think about the hardware, and I think about a system CPU, and anybody's CPU, whether it's IBM's or anyone else's, the way I think about the problems we're trying to solve today is that the system CPU just really isn't capable of solving the problem. Right? It just doesn't have enough horsepower to get the answers. So what we have to do is we have to design systems specifically for these types of workload, and that's what IBM did both with the Minsky and with the AC922. And that sort of starts with what we call the acceleration superhighway. So the AC922 is the first platform that uses NVLink 2.0. NVLink 2.0 is I/O technology that we're using not just between the GPU for GPU to GPU communication like other platforms, but we're also using it between GPU and CPU to increase the bandwidth available there. And beyond just increasing CPU to GPU bandwidth, it takes a balanced system, and IBM understands that. So we didn't stop with just just enhancing the bandwidth from GPU to CPU. We also added PCIe Gen 4 buses on the system to increase the bandwidth to communications adapters to make sure that we had high performance systems end to end. The goal here really is to combine the software and the hardware so that we can improve training times, improve inferencing on deep neural nets, right? And that was the design goal when we were building the platform. Please. There we go. All right, so the acceleration superhighway, what really is it? What are we talking about when we think about it on this platform, right? So there are really two main innovations there, and I indicated that we added, PCIe Gen 4 networks. Those are used primarily for communication systems and high-performance storage adapters, that kind of stuff. And then there's the 25 gig link. The 25 gig link is intended for use with NVLink to connect to GPUs to give us the additional bandwidth we need in order to be able to process large amounts of data. Right? Because this is a very big data problem, right? It's the ability to move enough data in and out of the GPUs fast enough to be able to get the answers. It's also, so one of the other things that's important about this, one of the other things that's important about this is OpenCAPI on the 25 gig link. One of the things that we did there is we added a coherence layer, right? And that this covers both NVLink and OpenCAPI. We added a coherence layer which basically enables easier development programming for accelerators on the, that are in the system. And it also enables the users, helps to enable users to go beyond GPU memory, right? So you heard Scott talking about large model support. The typical problem is 16 gigabytes of memory inside the GPU. Your model needs to be limited. It needs to fit in that. What we now have is the ability to go beyond that. And in order to go beyond that and be able to effectively move in and out, move information in or data in and out of system main memory to the GPU, we need a very fat pipe in order to be able to do it. So, last piece on this is are the on-chip accelerators for compression, decompression. Basically take those workloads away and accelerate those as well. So I talked about the pipes. I thought it'd be useful for you all to at least be able to see what this really means. So as we look at this chart, what we can see are the 150 gigabit links on the left side for the 4 GPU system, and the 100 gigabit links on the right side for the 6 GPU system. If we were doing that on standard commodity hardware, that would be PCIe Gen 3 at about 16 gigaseconds. Give you an idea of the difference engineered into these systems. Okay. So we'll switch gears a little bit now that I've talked about the hardware, and we'll talk a little bit about software-defined infrastructure in the form of spectrum computing. So spectrum computing is a high-performance workload management system designed for mission-critical reliability and extreme scalability. It's been in use for years in high-performance computing, analytics, and we're leveraging that in the AI, machine learning, deep learning, right? So these are some of the technologies that we use in order to facilitate the distributed deep learning, right? The ability to scale across multiple systems. Scott indicated, the use of MPI technologies, right? That would be Spectrum MPI, which is a part of Spectrum Compute. And then there's also, Spectrum Conductor, which is also linked in and used as a part of this. The goal here really, in a nutshell, is to be able to take tens, hundreds, or even thousands of computers and make them behave as one, right? Make it easy to access the resources of a distributed system, the same way we've been doing for years in high-performance computing environments. So, dropping down a level, right? Because we are talking about a lot of data into the software-defined storage. We're at spectrum scale. As I indicated, this is GPFS, right? So it's the rebranding of GPFS. This product's been around for a long time. It's very robust software-defined storage technology. It's been deployed at thousands of customers, and over 50% of the Global 100 use it today. So it's well accepted, it's well proven, and well-known software. And what it does is it provides a unification layer for analytics, file, and object data that spans the data center or even multiple data centers should you desire to do that. And I'll show you an example of that here in a few minutes. It provides a POSIX-compliant interface for I/O access. It also supports NFS, SMB, as well as object and HDFS protocols. And it does it all with a single global unified namespace. One of the things that you get here is, so in a lot of the, I guess, more modern paradigms, what you wind up doing is you wind up moving the compute to the data. What this allows you to do is it allows you to spread the data uniformly across the entire environment, no hotspots, right? So, and be able to access it from anywhere or everywhere, right? Throughout the entire system. So scale is vendor agnostic. So that, that means that you can run this on commodity hardware if you want. IBM also has the Elastic Storage Server, or ESS, that we use in conjunction with the software quite a bit. The scale-out nature of Spectrum Scale, GPFS, means that you get incremental scalability, incremental, consistent, and predictable scalability from very small environments all the way through very large environments that are capable of feeding the largest systems around. So I've talked about the Power 9 platforms and AC922. I've talked about Spectrum Compute. I've talked about Spectrum Scale, and I've even talked about the ESS platform. So all of these components are the components that we use to build the Coral systems that are being developed or being implemented right now for the Department of Energy at Oak Ridge and Lawrence Livermore. These systems, when they're complete, if I've got the numbers, oh, I'm sorry, I keep walking away from the mic. If I recall the numbers correctly, we're looking at about 300 petaflops plus of high-performance compute power in these systems, and 3 exaflops of AI compute power. So these will be these systems will be the largest systems, the largest supercomputers in the world when complete. And I think we're, what's a quarter of the way through implementation, something like that? So these are amazing systems, and these are the exact same technologies we've been talking about today, starting with a single system going up to thousands. So I'll leave you with a couple of thoughts. The first thing I want to say is that, IBM provides a pretty comprehensive solution stack around cognitive technologies, AI, ML, and DL. Given the work that we've been doing at, with the national labs, I think it's pretty clear that we've got a very, very strong commitment to the market space. And one of the other things that I'll mention is the Open Power Foundation. Open Power Foundation is a pretty robust community around these technologies. It's got about 300 members. Of course, it includes the labs. It includes organizations like Google. So it's a very robust infrastructure or support infrastructure around the platforms and what we're doing here. And that, I think, is all. Any questions? Excellent.
Thank you, Randy. Great job. Do we have Joe Woodward on the line?
Hey, Cynthia, Joe's here. Can you hear me?
We can, thank you. I'd like to introduce Joe Woodward. Joe is a senior managing consultant in our IBM Global Services group, focusing on the COCOMs. Joe is a retired U.S. Marine Corps colonel from U.S. SOCOM. He also holds a PMP certification and has been focused on bringing capabilities to Special Forces operators in the field. Prior to joining IBM, Joe was the Deputy Director for the Defense Threat Reduction Agency in J9CXQ. Joe's going to talk about some cognitive solutions and services and IBM's mission expertise, both for local cloud and hybrid delivery. So with that, Joe, I'll turn it over to you.
All right, Cynthia, thanks for the introduction, and special thanks to our MITRE colleagues. When I was in government, I worked extensively with MITRE and very familiar with the Bedford facility and what MITRE brings to our DoD partners. So thanks to them for hosting us. I really just want to spend my 10 or 15 minutes briefly to bring together and build on what the previous speakers, such as Lisa from Research, who started the day, and then obviously following Randy is always a tough ask given his competencies. But I really want to build and try and tie everything together that we've talked in this past hour and a half or so. Specifically, I'd like to introduce how IBM today is collaborating with our national security partners in the COCOM space, such as SOCOM and obviously CAM's team, as well as some of the things that have been alluded to briefly on the services side. Before I get started, I do want to mention, for those that want additional information, I encourage you all to jump on your favorite search engine and search for AI and Defense One. There you should find a sit-down discussion with our IBM Federal General Manager, Sam Gordy. And Sam and the Defense One host spend about 14 minutes really talking about the IBM approach to human-machine interface and the concept of augmented intelligence. So, again, for those that want additional information, I encourage you to do that. Could we go to the next slide, please? The next slide builds, so build through it till you get the three little balls there with the three pictures, please. Right, okay, thank you. So when we work with DoD and the concept of the third offset, the associated thinking for our DoD partners is all about the 21st century warfare and winning information in the decision space, either before or during the conflict. This concept is really what characterizes the strategy around fifth generation warfare that we'll talk about very shortly here. As a Marine, big fan of Lieutenant General Stewart, former DIA director, and now at Cybercom. And he always talks about the fight for information. Don't think that you're prepared for the war that you will face, and don't fight the last war. So those are, some things that General Stewart brought to DIA and is now bringing to Cybercom. So as IBM works with our national security partners, we see three major areas around challenges. First and foremost, in the upper right-hand corner there is one of digital disruption. Specifically, most organizational cultures are risk-averse, and that coupled with the exponential rate of, the growth of technology, you're going to end up with a gap in between that we've identified as digital disruption. So that coupled with singularity in the battlefield, speaking to potential breakthrough technologies that, some of which have been introduced this morning around intelligent machines, enhanced communications, AI, nanotechnology, and the like, all speak to different human-machine interfaces going forward. And on the concept of cognitive warfare, that third ball in the lower right-hand corner, this is really speaking to our adversaries' accelerated investments and efforts towards intelligentization of warfare or cognitive warfare. Specifically, their investments along the lines of the fifth generation warfare. Some examples of this is on our Russian adversaries in the Kalashnikov combat module. This consists of a gun connected to a console that constantly crunches image data to help them improve their target identification and improve their decision making, right? Now, on the plus side, some of the work that's happening at SOCOM that Cam alluded to that we're working with them on is some collaborative operations in the denied environment. So specifically, using one mission commander to control numerous drones at the same time. So ultimately, this would develop the flexibility so that the drones can operate in a denied area, communicating with each other, thereby protecting each other, and geolocating possible targets with their sensors in order to guide less capable munitions within that sensor range. So these are some concepts of fifth generation warfare that when we talk to our national security partners, this is sort of how we're talking to them. Can we go to slide 3, please? So staying with Lieutenant General Stewart, formerly at DIA and now at Cybercom, he also talked about wars turning on the ability to make good judgments. Simply put, and as a pilot, I embrace this concept. It's to know what to do and when to do it. He goes on to say, if you don't control information or your decision-making cycle is disrupted, your cognitive ability becomes degraded, and then you're able to not fight or win effectively. So when we talk about the past wars or fourth generation warfare being characterized as a decentralized concept, fighting terrorism and ending the nation state's monopoly on power, we then transition to the concept of fifth generation warfare, where it's specifically about the fight for information. And unfortunately, we're not the only group to be thinking this way. I'd point you to a lot of open source readings on the Chinese PLA leadership and the investments they are making in the AI world and their investments and belief in the future cognitive nature of warfare. Specifically, they believe that human intelligence may prove unable to keep pace with the new operational tempo of this new warfare, this fifth generation warfare. And at that point, as warfare occurs at machine speed, keeping humans in the loop, according to the Chinese PLA, that could actually even degrade certain aspects of decision making, thereby becoming a liability rather than an asset. I mention that because that's a fundamentally different approach than our DoD partners and how we approach it with the concept of augmented intelligence and meaningful human control. So again, I do want to point out that as certain adversarial groups make investments in AI and cognitive warfare, they are making different investments for different purposes than what we are doing. So any questions on that as I lay out a pretty broad scene setter there? Okay, can we go to slide 4, please? We're just going to throw that up and really move beyond it very quickly here, because I think really all the previous speakers, again, going back to Lisa opening and John, and most recently Randy, they've all talked about this information in the form of new platforms, new challenges, and new tools. What I want to really do is sort of tie it all together and talk about some solutions that we at IBM Federal are bringing to our national security partners. So go to slide 5. So when we talk to our partners, specifically in the combatant command and the services space, we talk about understanding, reasoning, and learning. Specifically, and those different levels of the various capabilities that a cognitive solution can bring. On the lower left, we talk about cognitive systems being able to understand information, similar to how we process it on the human side using NLP and other type capabilities. Next, we want to advance to a reasoning capability on the augmented intelligence spectrum. You've seen this in previous speakers' presentations. You know, I think we had, was it John that covered large model support, and then obviously Randy recently with the PowerVision AI, you know, as very capable reasoning systems and capabilities. Ultimately, we want to get towards the learning side of the cognitive system, and that's where the cognitive systems can become experts in certain domains as they continue to learn and adapt. At IBM, we speak to an out-of-the-box cognitive capability being similar to an intern. However, the goal is to become an expert in the field, and there's an element of learning, both on the human operators and on the data corpus and the system that is required. And that's the concept of how we get towards some of this cognitive learning. So this is a framework with which we talk to our DoD clients about. So going to the next slide, as we tie it all together under the concept of cognitive situational understanding, this is where we start to bring understanding, reasoning, and learning together as a offering. The IBM approach to situational understanding is where we're going to use cognitive systems to perceive elements in the information and data environment. You know, things, various facets within the text, images, sensor information, etc. You've all been introduced to that this morning through various capabilities. We then want to use those cognitive capabilities and systems to try and comprehend the disjointed and that dirty environment that was introduced today in the context of the mission goals and objectives for our national security partners. This is where we go about uncovering and correlating insights in the data, such as relationships using models enhanced with machine learning, all with the goal to provide previously unrealized correlations and additional insights in the context of their mission and objectives. Finally, on the projection side, this is where we're employing the learning elements of the cognitive system to actually employ predictive analytics and, where possible, prescriptive analytics that John previously spoke about. And this is ultimately about that human-centric design and the improved decision-making, ultimately to improve your performance in the concept of fifth-generation warfare. As we go to the next slide, on slide 7, you're going to see a couple of examples of where we bring that to bear and have actually offerings in the field right now with some of our partners. Specifically on the left-hand side, behavioral health for veterans. This grows out of our Watson Health vertical and is being supplied in support of our warfighters today. In the middle tier, I believe it was either John or someone else alluded to what we're doing with LogSend U.S. Army for striker maintenance. And this actually grew out of a previous example that was discussed, predictive maintenance for our commercial aviation assets, right? So we have a cognitive system on site down in Huntsville that has been trained and ingests not only real-time maintenance data from the strikers, but the maintenance manuals. And we are getting excellent results on doing preventative maintenance for that fleet. On the right-hand side, lower right-hand corner, talk about cybersecurity. IBM just introduced late last year a cognitive capability around cybersecurity, where we bring our Watson capability into our latest SIEM offering with QRadar. That's being deployed successfully and employed successfully at several DoD partners. So there's no questions there on some of those offerings. We can go into other ones. I'd like to go to slide 8, please. So I'm going to leave you with two examples here, a little more deep dive into what we talked about on the previous slide. So right now, for those that don't know, of note, the United States government currently has the most complete and integrated cognitive solution in use today. It's on JWICS. It's a long-time collaboration between IBM, some other corporate partners, and the U.S. government, using government data and training that data with IBM and government SMEs. This solution supports intel analysts across the government today. Again, on JWICS, we anticipate getting some aspects of it onto CIPRNet here during this calendar year. Next slide, please. On the flip side, if you don't want to have a whole system that I just introduced previously, and this really builds on what John talked about as far as IBM Data Science Experience and our API offerings. We've got a myriad, I believe we're over 165 APIs now, cognitive APIs available that you can employ against your own data via our DSX API offering. And this can be cloud-based, as John alluded to, or there are aspects that can be brought on-premise to augment your on-premise analytics as well. So this is out there. John talked about how to get a hold of that. I think Cynthia's made some offerings as far as free trials available for people who are interested. So next slide. And really what I want to do here is I'll end with a quick overview of our IBM cognitive solution concepts. And really it's with the idea that we should practice as we play. When we talk to our partners, our narrative is the time for cognitive solution employment is now, right? We are getting some success within the national security sphere, and there are some early adopters who embrace that. We advocate, wartime, real-time serious games, simulation of real events, and resource allocation using cognitive solutions. Do it now, practice as you play. Improve your operational readiness through inventory optimization, predictive maintenance. That's happening now. That's growing out of our commercial side and having significant success on our national security partner space. We advocate gaining actionable insights and situational understanding, both in a common operating picture, common intelligence picture, so think COP, SIP, as well as from a network picture, so think cybersecurity and cognitive capabilities there. We believe the cognitive solutions is a force multiplier. It's a concept of one warrior with the power of many warriors. Augmented intelligence doesn't sleep, it doesn't forget, and it can consume massive amounts of data with the intent to provide real-time, situationally accurate updates, right? So it's really the concept of a force multiplier and augmenting the human decision-making process that unfortunately is just going to get more and more overwhelmed as we get into the concept of fifth-generation warfare. Let's go to my last slide here. So really, pending any questions, thanks, Cynthia, to facilitate. Thanks to all the IBM speakers who participated, and a special thanks to our MITRE team that hosted us. Look forward to working with them in the future. My contact info is there. I would encourage everyone to reach out to Cynthia. She and I work well together. She lives down here in Florida with me. So if you need anything at all from the IBM GBS team or the federal team, just let Cynthia or I know. But again, thank you all for your time. It's an absolutely great topic. It's relevant today. It will make a difference going forward, and I look forward to working with everyone. So thank you all.
Joe, thank you. We have a question from the room from Russ Graves from MITRE.
Hey, Joe, from your experience on getting to the cognitive answers and solutions, how challenging is it to get the data correct so that you're getting actionable or better insights? How long does that take to, find the right data, clean up the data, keep the data current?
Russ, right, great question. So, Cam alluded to this as far as the dirty nature of data for SOF. There's a component of governance and provenance. I think we had a couple speakers, maybe John talking or Scott talking about, the government embracing, a data lake concept where they just pour all their stuff into there and it's just dirty and nasty data, right? So from our perspective, it's a significant challenge, and vice quantifying it in time. I mean, obviously that changes depending on who you're working with, how much data they have, and what type it is. What we do talk to them about is a cognitive approach to data governance is better than a non-cognitive approach. And what we find is immediately two things become jump out of that. First and foremost is the ability to correlate insights that weren't previously there. And the other thing that jumps out is you realize, and this is kind of counterintuitive sometimes, you realize what data you're lacking, and that lacking can be a quantifiable lack of data, i.e. I'm missing data sources from sensor ABC or component 1, 2, 3, or it could be a more qualitative miss that I think you're alluding to, Russ, which is one of this data is not going through the correct governance and provenance processes, and it is by definition dirty. And the issue we have there is if the customer does not and the partner does not train the system through appropriate adaptation, you end up just like we would with our kids, right? There's no such thing as a bad kid. There's just bad parents. It's the same thing with a cognitive system, right? If you train it with dirty data, wrong data, you're going to get the wrong results from your cognitive system. So, very long-worded answer to what should be a fairly simple question, and I apologize, but it really is about provenance and governance. And so from an IBM perspective, when we run into those partners that don't have a governance and a provenance system in place, it's very much building the airplane as you're flying it. And so as we bring the cognitive approach, we want to focus on the data that is less dirty, train the system, set aside the data that has not gone through the appropriate processes, and then simultaneously work with them to implement a governance process. So again, depending on who they are, what they have, it can be a laborious process, but it is one that once you start down that path, you find that you progress very rapidly, because that is by definition the nature of what we bring to bear on the cognitive side. Was that helpful at all?
Yeah, you addressed it exactly right there at the end, so thank you.
Okay, thank you. And for the record, Cynthia, I think I was the only one to get a question from the audience. So
I knew you were going to bring that up, Joe.
I finally got brave enough.
Any other questions for Joe? All right, Joe, thank you.
No, thank you. Have a great day.
Thanks. So just to wrap up, I want to thank everyone who, first of all, came here in person in Bedford to attend, our MITRE partners for hosting us today, all of our speakers and our attendees on the phone. We have folks in attendance from Air Force, from Department of Defense, around the Federal System Integrator community, and a number of customers and our IBM Research colleagues. We will be sending out a survey as a follow-up, so if you think of questions later, we'll be glad to answer them. I'd like to reiterate our offer on our data science experience trials, whether you'd like to do it in the cloud or on-prem, on your own systems. We also would love to engage with you if you'd like to set up an Power AI system on-prem. We'll be glad to make those arrangements for you, of course with an appropriate test plan and schedule, so we know what's happening with that gear. We'll make the slides available and publish those, probably in PDF format, and we'll coordinate follow-ups. So we would like, during the survey process, if you can name your areas of interest, and we'll set up a collaboration process where we'll connect interested folks with the right people at IBM and come in for deeper dives or whatever the requirement is. So before we conclude, any final questions or comments from the audience? Very quiet. All right, well, thank you very much.
So I'll just say thanks very much, Cynthia, for coming here and putting together this tremendous agenda. I'm getting all the different speakers to present. I know the challenges of we dry rehearsed everything yesterday to make sure it all worked, different bandwidth today, so some different challenges. But I appreciate the speakers, if they're still on, for participating remotely as well as in coming in person. So thank you, very appreciative of your information you shared with us today.
Thank you, Russ. Thank you, Marissa.